Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment. Hi, today we will learn how to deploy multi-container applications to Azure Kubernetes services. So here is the agenda. First, we will understand what is multi-container images. Then we will understand a solution which we are going to build step by step. In this solution, we will first start deploying the resources required for the solution to run via the Azure CLI. So we will see what are those resources. Then we will dwell deep into the build process with Docker Compose and what are the different override settings for the build process. Then we will um, learn about Docker Compose and different build configurations supported by it. Then we will jump to Dockerfile configuration used in this demo, and then Kubernetes configuration used in this demo. And finally, we will learn about build pipeline and its stages, and then release pipeline and its stages in Azure DevOps. Once we understand all this theory, we will implement these concepts in a live demo, and we will discuss what are the steps we are going to perform in this demo. So let's get started. Let's understand what is multi-container app. As per the basic fundamental principle of container design, that each container should do only one thing and it should do it well. So we will understand this concept with an example. Here we are going to design a three-tier application, and in this three-tier application we will have front-end pod which will be hosting the web server, back-end pod hosting the middleware component, and then SQL Server to host the database. And these three components should interact with each other as one application because these are dependent on each other. If SQL Server is not there, you cannot use your front end to display the record which is coming from SQL Server. And same way, if you are trying to call stored procedure from backend services, you cannot call those stored procedure if SQL Server is not there. So they are interdependent to each other, but they act as a single app, which is deployed into multiple containers. So that is why it is called multi-container app. So this is a solution overview. In this solution, um, first we will build this image by getting the basic standard image from Docker Hub. Okay, and this is the standard image which is uh, designed and developed by Microsoft and pushed it into Docker Hub. So this is a standard base image which we will be using, and then on that base image we are going to customize that image and copy our code into that image and then build that image. Once that image is built, we will push this image into the private container registry in Azure Container Registry. And then we will use Azure Pipeline to pull this image from Azure Container Registry and push it into the Azure Kubernetes Services. In Azure Kubernetes Services, we will have pods. The first one is front end, another one is back end, and obviously we have Azure SQL Server. And all these components, they are actually hosted. Azure Kubernetes Services is hosted in the 3-node cluster which we are going to create. For this solution, we will deploy the resources, and these are the list of resources. We will deploy Azure SQL Server. We'll deploy Azure Kubernetes Services with 3-node cluster. We will also deploy Azure Container Registry to host these container images. We will create a DevOps organization. Then we will create the Azure pipelines. There will be two set of pipelines, one for building, another one for releasing. And then we will also create a service principal and role assignment so that Kubernetes can get the permission to access these images from the Azure Container Registry. Okay, so let's understand how we will build this via the help of Docker Compose. Docker Compose has a option called Docker Compose build, and we will create a compose build file. Okay, and this build file will be used to create the custom image. So this is the example, this is the exact configuration we are going to use. So let's understand this compose file. In this compose file, we are going to use this ASP.NET Core build, which is a standard image created by Microsoft. We are going to pull that image. Then we will create a volume. In this volume, we are going to mount the current directory where this compose file is hosted, and then we will mount it as a slash source. And then in the next step, we are going to put working directory as a same slash source, so that whatever command we are going to perform in the next step in the command will be worked on this source directory where all our files are kept. And this command is very standard command whenever you deploy any .NET resources and compile those .NET resources. So first step of this command is to restore all the NuGet packages, because in .NET solution we have many NuGet packages and we need to restore those NuGet packages. So once we restore those NuGet packages on the solutions, then the next command we are going to publish, and this publish command will compile and publish the output into the specific directory. And here we are using two switches. So O switch means it is on to the output is going to the particular directory, and C switch specifies the configuration. In this case, we are using the release configuration because we will be using this configuration or in our release pipeline. So we want to make sure that we are using a release configuration. Release configuration means that this release configuration is suitable for the production workload. It will not have any unnecessary packages. It will be very lightweight. Okay, so here we are also adding another file called Docker Compose override. This override file can be used to override the setting given in the Docker Compose CI build file. Okay, so this is used when you want to change the configuration, different configuration for dev, QA, and prod. And we can define these environment variables here, and we can also customize different ports based on your requirement. Like you want to deploy the dev builds onto 80 port and QA build onto 81 port, and then production build to 82 port. So all these override we can do it in the Docker Compose override. Let's understand Docker Compose. So generally we can define multiple Docker Compose files. So for example, we can define Docker Compose main file where we define all the services required to run. And this file should only contain the services and their images. Then we can define another file called Docker Compose run, which can define the runtime parameter used for running the images. And these runtime parameters can be different for each environment. Like for dev, QA, and prod, you can use a different run file. And then there is another set of file where we can provide a Docker build file. So Docker build file is used to build the images. Okay. So in this example, what we have done is we have created a Docker Compose file, and the real instruction to build this compose file, the images kept separately. Instead of putting everything in one file, we have, for the sake of clarity, we have put it in the separate Docker file. So let's understand how it works. So build is used to specify the configuration option at the build time. So this is a build element, and then this is a context and this context means what is a path where your Docker file is kept, so that whenever you run this build, this Docker file will be used. And this is the image which will be built when we will run this Docker file. So as discussed, these are the other build configurations. So in the first configuration, we are going to build the image, and this is how we can do it. The first Docker Compose file is there, f switches file, and then this file will be used as a standard file, whether you are running the container or whether you are building. And then another part of this is in the build process, we are using a build configuration, and while running it, we are only going to use the Docker Compose run. And this run can be customized for different environments. So this is for running the container, this is for building that. And if you see the switch is also there, build switch. And in case of running the container, we will just use Docker Compose up. To stop the container, we will use Docker Compose down. So let's understand the Docker file configuration. And this is a file responsible to build this solution, and we are getting this standard Microsoft image from Docker Hub. So from means it is getting this image, and arg is defining a variable which can be passed at the build time, and it is using the working directory as /app. This container will expose the port 80, and copy will be used to copy from the location specified in the at source, and then it will be also using the copy the values to copy the binaries to the publish location. Okay, and this source is nothing but it is coming from this argument. So whatever the argument you are going to pass, it will get it here and then copy it to the publish from that location to this location. And then entry point is used to run that image. The entry point, standard entry point in the Docker file. Now let's understand the Kubernetes configuration. Kubernetes configuration is used to deploy the pods into the Kubernetes. So first is the deployment configuration, and here we are creating a label so that we can use that label to communicate to that particular container. If you see, this is a backend pod, and this is a deployment configuration file. Here we are using number of replicas 1, and label. When this label is found, the config will be applied based on the pod where the label is kept. So if suppose the label is different, then the configuration pertaining to that particular label will be applied to that pod. And here the specification is, this is a Redis image, and this in this case container will be using the 6679 port. Here for backend port, we will be using cluster IP service. Cluster IP is a service used for the internal communication between different pods. It creates a internal IP address, which can be used to communicate to each other. And then they will be using 6379 port. And then this is another configuration for deployment, which is called MHC front. We have used rolling updates, which means that whenever the new updates are coming, there will not be any service interruptions. And it also specifies multiple different configurations like max unavailable, that how many nodes, how many pods are unavailable at a particular time, what is the minimum number of pods which should become available in, and then what is the how many seconds it takes to make them available. And here we are using this container registry. In container registry, we created an underscore ACR underscore. We will be using one of the pipeline to replace it with the real ACR name, container registry name. And for the front end, we are using the port 80, and then these are the CPU limits for the pod. Because if you don't specify CPU limit, it will consume all the CPU limits or CPU on the node. So it is a good practice to specify the CPU limits. Here, again, this is a Redis, and then there is another service which is called the load balancer. And in this load balancer, why we are using it, because we want that all the requests should go via the load balancer, and then it should go to the particular node and equally distribute among the nodes. So in this, again, the load balancer is listening at port 80, and that is how we created this listening to port 80. So now let's understand the build pipeline stages and the release pipeline stages. So in build pipeline, we will be using these pipelines. First step will be to change the name of the ACR, Azure Container Registry, and this will be changed in the app setting JSON file. And then run service. In run service, we will pull the image and then restore the NuGet packages. And then build service will be responsible to build the image, and then while building the image, it will tag the image with the build ID, okay, and then push this to the registry. So if you see, this build service is building it, and push service is pushing this image to the Azure Container Registry. Once you have this image available, then you will publish these artifacts, including your DAC file. DAC file is nothing but your SQL Server SQL instructions to create tables and required schema, and then AKS YML file is responsible for deploying the AKS. So all the pod configuration will be written in this. We already discussed it in last slides, and these files will be published to the artifact drop location, so that once this publish pipeline is completed, the next step is going to be used for the release pipeline. So these artifacts will be utilized in the release pipeline. So let's see what is this release pipeline looks like. So first step is a publish, and then second step is a release. And in this release, we will have these set of pipelines. So first is execute this DAC pack, that means populate the tables into the Azure SQL Server. And then these are the deployments for AKS. So in this, the first step will be to create the deployment and services based on the AKS configuration we have just discussed. And then second step is to update the image in the AKS. So let's jump to the demo. In this demo, these are the steps we're going to perform. First, we will deploy the SQL Server. Then we will create Azure Container Services. We will deploy Azure Kubernetes Services. We'll create these pipelines, and instead of creating this pipeline from scratch, we are going to use Azure DevOps demo generator, because this demo generator will create so much code automatically instead of rewriting that code. So it's you don't have to write this code from scratch. Then we will configure the pipelines and then trigger this pipeline to see how it works. And then we will also see whether the application is working fine while verifying the deployments. So let's jump to the demo now. Okay, so first step in this demo is we are going to create all these resources which is used for this demo. I have used Visual Studio Code, and I have created Azure CLI scrapbook. And then this is the code we are going to go through. First of all, I'm going to log into Azure with the Azure AZ login, and I have already logged in. And if you see this is a login subscription and tenant information. I'm using this tenant. Now I have created multiple variables, and these are the variables. So if you see these variables, they are used in our commands, like what is the location, resource group name, SQL name, AKS name, and then ACR name. So these are the variables we are going to use. Then let's create a resource group first. So this command will create a resource group. And you can see that resource group is already created. And then we will create the AKS cluster. Before creating the AKS cluster, we will find it out what is the version. which is supported by Azure. So this is the version 123.5, and then we will create a AKS cluster. So this AKS cluster will be using all these variables like resource group name, and then we will also add the monitoring capability. Kubernetes version, we are going to use the latest one, which we have got it stored in the variable version variable, and then we will generate the SSH key, so that in case we want to log into that AKS cluster, we can use this SSH key. So let's create this cluster. So we started creating the cluster now. Okay, so now AKS cluster is already created. We will create the logical server to host the SQL DB. And all these parameters, SQL name, admin name, and the password is specified. And let's run this command. Okay, so now the server is already created. Let's create the firewall rule so that all the Azure resources can access the SQL server. So this is a firewall rule. Okay. Now, if you see here, you can see that these resources are already created, and here allow Azure services and resources to access the server is yes. Before that it was no. Okay, so that means this is successfully done. Now let's create a SQL DB. SQL DB is successfully created. Now if you want to print the name of the logical server which we created, and you want to print it in the CLI, you can use this command. So this is your multi-container SQL.database.windows.net. This is the name of the logical server. Now we will create the Azure Container Registry. So this is the Azure Container Registry we are creating. And the next command will show you the name of the registry. So this is the name, multi-container acr.azure.cr.io. Okay, so now let me show you these details, how it is looking like. So these are the resources which we created, and this is a cluster, this is a registry. Okay, so this is a multi-container registry which we created, ACR, and then if you see this access control, there is nothing in this. So now let's run next set of command. So here we are going to retrieve the service principal which is configured for the AKS, and then we will create a role assignment so that the role can be assigned and AKS can access this registry. So this is the client ID of the which is created, and then we will retrieve the resource ID of the registry, because whenever you create role assignment, you need to have the service principal or client ID, and then you need to also have the resource ID of the resource against which you want to assign that role. So we are going to assign the role against this ACR. So this is a ACR ID or resource ID. So if you see here, this is the resource ID. Now we will create a role assignment. Okay, so after we created role assignment, let's see what do you see here. It started showing you these values, and this is the ACR pull role assignment we just created. Okay, so that means you are successfully able to create the role assignment. So this role assignment is very important because with this role assignment, um, AKS will be able to access the ACR. Okay, now in order to log into the AKS via SSH, we need to use the AKS get credential command, and this command uses this AKS name and resource group name. So we are dynamically finding the AKS name with this query, and once we know the AKS name, then we'll use the get credential. So now the credentials are, it is asking whether you can merge the credential or not. Yes, you want to merge the credential. Okay, so what it does is it actually merge the values in the kube config file at this path, and whenever you add any extra set of credential for new AKS instances, it will keep adding those values in this config file, so that when you run any command like kubectl get pod or kubectl get service, it will use these credentials from the config file. So at this point of time there is no pod, so it will show you nothing. So it's not showing anything because it is just a plain vanilla AKS instance. We have not created any pod or anything, but we are going to create a pod with the help of Azure DevOps pipeline. Okay, in order to do the faster development, we are going to use Azure DevOps demo generator, and this helps you to create a project and all its dependencies in one shot. So I will show you how to use this. First, you're going to sign in. It will ask you which your credentials. So I already entered my credential, so you don't have to again enter it here. You can choose the template you're going to use. So there are multiple templates. I'm going to use this Azure Kubernetes Services template, and then selecting the template, it is going to ask me the name. So I'm going to put the name as deploy multi-container application to AKS, and the organization I have two organization. I'm using this second organization, and after that it is going to ask you verify if all required extensions are installed and enabled. So in case if you are trying this demo and if you see that these extensions are not enabled, what you can do, you can come here, click it, okay, and then you can say get it free, and it will allow you to install these extensions like this. So if you want to use a different organization, you can use different organization. And because since I already installed it, it is showing me that you don't have to install it again. But if you want to use it for the different Azure DevOps organization, you can install it, and it is one-time activity. You don't have to do it multiple times. Okay, so it's saying that it's already installed. But if I go to other organization, I can click install, and then it will automatically install it. Same way it is going to ask for replace token extension, so you can add that extension if you want, and once you're ready you can. So let's create this project here, and if you see it's started creating this project, it will be pretty quick. Okay, so now it created the project, and let's navigate to the project. So this is the project which is created. Okay, so now the demo generator already created the pipelines. So let's see what are these pipelines looks like. So first we will go to the pipeline. This is a build pipeline, and this build pipeline is based on this YML file. So let's click this build pipeline and see what is there. So this pipeline is going to use the agent Ubuntu 18.04, and these are the activities in the pipeline. So first activity is to replace the token in app settings.json file. So let's see what is this app setting.json file. So for this, I'm going to go to the repo. In the repo, if you see app settings.json, this is app setting.json. And in this JSON file, there are entries which need to be updated, and those entries need to be updated with the token. And what are those entries? We are going to change the SQL Server name. We are going to change the SQL user and then passwords. So these are the values we will change, and all these entries are following the same pattern, like underscore and then password underscore. Similarly, underscore SQL user underscore, and then server SQL server underscore SQL server. So these entries we need to update. Similarly, there is another activity replace token in MHC AKS file. In MHC AKS file also, if you see this MHC AKS file, AKS YML, again this require changes because in this file also you will find the ACR, and then ACR entry need to be changed, like this one underscore ACR underscore. So once we run the pipeline, these two tasks will update these values, and from where these values will be updated, these values will be updated on these variables. So first we will put those variable names, like what is ACR name, SQL password, SQL server name, SQL username, and when these pipelines are going to be triggered, these values will be replaced while these tasks will be running. So let's update these variables now. So first we will update the ACR name, and the ACR name is this. ACR name we are taking it from here, multi-container ACR.azure.cr.io. Similarly, for SQL password, we are going to use these entries. So SQL server name is multi-container SQL.database.windows.net. So let's copy it here and paste it here. Similarly, SQL password is already used this password. And then SQL user, which is SQL admin. And let's save this. Now let's change the pipelines. So in this task, we need to search the pattern. So we are going to search this pattern, because if you see the values are in this order only, underscore name underscore. Similarly, for this another task, we are going to use exactly same way. And let's save it. So now both the values are showing same thing. Now we'll come to another task. It is going to ask you the Azure subscription. We'll use the Azure subscription and authorize this. Once you authorize it, it will be already taken as a service connection, and these service connections will be saved. So then next time when you are going to save this service Azure subscription, it will be there. So let me show you once this authorization is done. So why we need this authorization? Because you can use any subscription. Now it is already connected to your subscription. You can use the container registry. So here the container registry, it is showing multi-container ACR automatically. And here it is going to run this by creating a, once this task is running, it is going to build the image, and this all these values are populated here. Now let's save it and then move to the build services. For build services, again, it's going to ask you the container registry name, and here this service connection is already established because you have established this service connection in the run services task. So here you need to just select it in the available Azure service connections, and then here again is going to ask you the container registry name. If this does not appear, just refresh it, and while building, it is going to create the tag build.build ID automatically. And let's see if there is some other values we require. It is required to set up here. No, we are good. So let's save it. Now let's go to the push services. Again, in push services, you need to specify the existing service connection. You need to specify the container registry name, and then it is same thing. It is going to push. This activity will push the image to the ACR. Lock services. This is very important. Why? Because lock service actually locks the image by putting the digest information. Okay, so let's understand what is this lock services. So most of the time when we use an image, it is a tagged image, and these images in the container registry is mutable one. So with the appropriate permission, you or any of your colleague can update, push, or delete this image with the exact same tag which you are using. So when you deploy this image to the production environment, you are not sure whether this is the same image which you updated or your colleague updated or somebody else updated. So how do we make sure that image which you want is there? It is not the image which is created by another person with the same tag. So in order to avoid that, this lock service is being used. So lock service, what it does is it actually uses a digest information, which is SHA-256, and this SHA-256 is calculated from the image, and it is very unique, and it is identifiable based on that particular image. Okay, and any changes which you are making in the image, the corresponding to SHA-256 digest value will also change. So this is a unique way of making sure that you are using exactly same image which you have built, not the image which somebody else built. So that is why we need to use this. So now let's change these settings. It already took this Azure subscription, and rest of the things will remain exactly same. Let's see if there are other values we need to update. Everything is same. And then copy file, you don't have to change anything because this is copying the file. And a copy file actually copies these two things: DACPAC file. DACPAC file is the file which contains all the SQL instructions, SQL like the table schema and the data in terms of SQL, and then YML file is used to populate the AKS pods, deployment service information. And then there is this publish artifact. Publish artifact is the last activity because this will publish all the build information, everything it is going to publish at the end here. And then this is the place from where the release pipeline will take the values and use it. So this is very important. Okay, so now let's see, is there anything which we need to change? No, everything looks good. Make sure you save it. So now let's move to the release pipeline. In the release pipeline, so let's see what is there in the release pipeline. So first step is a build pipeline, which is this step, and then there is this release pipeline, which contains 2 jobs and 3 tasks. So these are the 2 jobs and then total 3 tasks. First job, we have execute SQL DACPAC task, and then in the second job we have this create deployment and service in AKS and update image in AKS. So let's see what is the agent specification. For this task, the agent specification is Windows 2019 because we are using SQL Server. and SQL. Here we are using Windows 2019, and for the AKS deployment we are using Ubuntu 18.04. Let's see what are the variables we have. So again, these are the variables we need to populate before we proceed further. Okay, so let's populate these variables one by one. First of all, we need to specify the ACR name. So for us, the ACR name is already given here. So here is your container registry name. Let's copy it here. Similarly, your database name is correct. Password is also we need to copy, and we have this password. This is exactly the same password. Then SQL Server name. So this is our SQL Server name. And then SQL username is same. While we created SQL Server, we use this SQL username SQL admin. It's already there. And let's save these values. Okay, so now go to the tasks. In the task, it's going to ask you the same Azure subscription. You already have the existing Azure service connection, and the remaining set of things are already there, so we don't have to worry about it. And this particular value we already given firewall values, which is already given, so it's already taking that value. And when this comes, that means it is perfectly all right, there is no problem. And if these tasks have any issues, then it will show you some settings needs attention. Here we can use again the same Azure service connection, and then if you refresh it, it will give you the resource group name. You will get the resource group which you are using for this, and then Kubernetes cluster name. This is multi-container AKS cluster name. And again here you need to specify the Azure service connection, and config map and everything is remains the same. There is nothing you need to change here unless it is asking you the subscription information. So this is also good. Now let's come here. Again, it is asking the subscription information. We'll use the same one. It is asking resource group, Kubernetes cluster name. We are not using any specific namespace, so we are good. Again, it is asking subscription information. ACR, where ACR variable will automatically take the registry information. So looks like everything looks good. Let's save this. Now let's run this pipeline. So here this is a build pipeline, and we will say run pipeline. Let's select run. So it is going to create the phase 1. Let's see what is going on in the phase 1. So it automatically populated all the tasks, and it is running one by one all these tasks. So let it finish all these tasks. It will take a couple of minutes. Okay, so all these tasks are successfully completed, and let's see the release set. release is still going on. If you see, this is still in progress, and if you click it, now it is executing the DB deployment task. You can see the status of each task one by one when as and when it is executing. It is also showing you the seconds it took or second it is taking. So let's wait for it to finish. So now DB deployment job is already finished, and now it is executing the AKS deployment job. Okay, so now we can see that all the tasks have been completed, including AKS deployment task. And this is a log for each of the tasks. You can go to next task and see the log. So that means all build and release pipelines are successfully completed. Now let's test whether it deployed these pods or not. So we are again back on the Visual Studio Code, and we are going to run get pod command. See whether the new pods are visible. Yes, these two new pods, front and back, they are there now. And then let's see what is the IP address of the service. So this is the external IP address of the service, and we will use this IP address to see whether there is any web application being deployed and it is visible there or not. So this is the external IP address of the load balancer. You remember we created a load balancer service. So all the users will hit to this IP address, public IP address, and then they will be forwarded. This request will be forwarded to the pod, and then from there you will be able to see the website. So let's see whether it is working fine or not. Another thing we need to note that this is a 80 port. It is visible on 80 port. So yes, it shows that the website is deployed. This website is coming from the pod.
Thanks for watching, and do not forget to subscribe and hit the bell icon so you don't